Welcome to the project presentation for Applied Innovations in Technology, presented by Team 7. Team 7 consists of Susan Bellhausen, Jeremy Brown, Jeffrey Flack, and Michael Thompson. We'll begin our presentation with an industry analysis of the United States auto manufacturing industry. The auto manufacturing industry sector has a great impact on the U.S. economy. As of 2010, the U.S. auto manufacturing industry employed approximately 674,000 people. And, when taken alongside consideration of ancillary industries in the supply and distribution chains, the U.S. auto industry affects over 3.6 million jobs nationwide. Over 14.7 million cars and trucks were sold in the U.S. in 2012. Since buying a new car is a significant investment to the average American, this is a very healthy number that is increasing with the population and as the economy improves. The total revenue for the U.S. auto industry was around $609.3 billion at the end of 2011. And the original equipment manufacturers, or OEMs, of the U.S. auto industry produce approximately 4 to 5% of the U.S. gross domestic product. Clearly, this is a significant industry in the U.S. economy. The major competitive force impacting the U.S. auto industry is that of barriers to entry. The premier barriers to entry are resources. Consider that the top 7 companies have over $500 billion in annual revenue. Startup is extremely expensive, and the business is risky. Reputation and loyalty. Automobile consumers are often quite loyal to a brand and reluctant to try a new model because of the large investment that an auto purchase represents. This makes it difficult to gain a foothold in customer sales. And finally, experience. Some of the auto manufacturers have over a century of industry experience and relationships, such as General Motors, which was founded in 1903. Such established companies are fierce competitors. The competitive landscape is composed of 13 mainstream corporations, with the top 7 holding about 48% of the market share. The remaining 6 U.S. manufacturers held 16% market share in the U.S. The company that we selected from our industry study is a rising star in the U.S. auto manufacturing industry. It's currently in the other category for market share, but is meeting the competitive forces head-on and making huge gains both in the United States and globally, steadily posting record sales in recent quarters. VW is headquartered in Germany and distributes products in 153 countries throughout the world. Volkswagen was founded by Ferdinand Porsche in 1937 and has had a solid U.S. presence since the introduction of the popular VW Beetle in the 1950s and 60s. It opened its first manufacturing plant in the U.S. in Tennessee in 2011, and it has plans for expansion of additional North American plants as part of its strategic plan to become leading auto manufacturer in the world. In its global operations, VW produces 37,000 vehicles per day, and in 2012 produced over 9 million vehicles. In addition to mass consumer vehicles under the Volkswagen brand, it also owns a number of brands spanning the different market segments, including a high-performance and luxury vehicle such as Bentley, Lamborghini, and Porsche. While performing a SWOT analysis to assess the strengths, weaknesses, opportunities, and threats for Volkswagen of America, we can see several items to consider in Volkswagen's operations. Let's look at a few of the main points. In the area of strengths, we see many things, but most notably that VW is strong, efficient, and knowledgeable. In the area of weaknesses, we see that VW has low market penetration in the US, and that it's behind the competition because it's lacking any form of telematics in its main Volkswagen brand line of vehicles. This brings us to VW's greatest opportunities that can make up for its weaknesses. It can improve its vehicles with added telemetry and capture market share. Finally, while there are a few, one of the largest threats to U.S. operations is that more stringent fuel efficiency requirements from CAFE legislation. This will require investment on VW's part for engineering development to meet. For this analysis, we see that Volkswagen has a golden opportunity for improving the bottom line in warranty management. According to its 2011 annual report, Volkswagen spent $7.5 billion in warranty expenses. And in this first chart, we can see that Volkswagen has the second highest dollar allocation of warranty and repair expense accrual per vehicle among the top 8 auto manufacturers who sell in the United States. In the second chart, we see that among European manufacturers, Volkswagen has the highest percentage of warranty cost as a percentage of product sales throughout the decade, ending at approximately 5.3% in 2011. There is a clear opportunity here for Volkswagen to reduce its warranty and repair costs while improving its competitive standing. And, while there are several possibilities for applying innovations such as increased development and utilization of Web 2.0 or machine-to-machine technologies, these aren't the best choices for warranty management. Fortunately, there is a technological solution. Given these facts, we are pleased to introduce the Vehicle Information Management System, or VIMS. VIMS harnesses the power of big data by capturing and analyzing information acquired from vehicle telematics to reduce warranty expenses, improve vehicle reliability and design, and increase revenues for Volkswagen. VIMS consists of a network of diagnostic sensors built into each major warranted component that record information on vehicle function, including engine and transmission performance, electrical and safety systems, environmental conditions like temperature and humidity, and other germane functions. This information is transmitted daily via wireless technologies to VW for compilation, analysis, and storage. If a vehicle begins to develop a problem, VW can send an alert to the vehicle owner and to a dealership or service shop of the owner's choosing. Using this data, VW can ensure the dealership or service shop has the necessary parts or supplies needed for repair, effectively preemptively supplying a part because failure can be foreseen. VIMS data can also be analyzed to determine which components are more likely to fail and under which conditions. By identifying patterns of failure, manufacturing processes can be improved, and suppliers whose parts may be more prone to failure can be identified, ultimately increasing reliability. While VIMS will be built into new Volkswagen vehicles, participation will be voluntary. New owners will be given an opportunity to opt in when they purchase their vehicle. To encourage owner participation, incentives could be used, such as extended warranty coverage, customized warranty coverage, which can both increase revenues and satisfy the customer, fuel cards or gift cards, or discounts for other services. VIMS participants can also receive monthly reports on their vehicle's performance along with scheduled maintenance reminders. VIMS offers both short and long-term benefits. Within the short term, VW can use VIMS data to better match parts inventory to anticipated need, reducing the inventory on hand and increasing cycle times. VIMS will allow for faster, proactive diagnosis of vehicle problems. Owners can be notified of an issue before it begins to affect vehicle performance so they can get it corrected sooner. All of these benefits will lead to improved customer satisfaction. And finally, we have an opportunity to bolster warranty sales revenues by offering customized extended warranties that are better for low-risk condition drivers or more realistic for high-risk condition drivers. In the long run, VIMS will help VW gain better knowledge of how its vehicles perform in real-world conditions, which can drive engineering improvements leading to improved vehicle reliability and design. Analysis of VIMS data will determine which parts are more likely to fail, which VW can use in its supplier management. The improved customer satisfaction will lead to increased customer loyalty, which can drive future sales. And finally, VIMS data will lead to Volkswagen having a sustainable competitive advantage with proprietary organizational knowledge that cannot be easily replicated. The balanced scorecard approach lists a number of organizationally holistic metrics to measure success. From the financial perspective, success measures include sales of extended warranties, yearly warranty and recall costs, total warranty services performed, and vehicles affected by recalls. Business process measures would include budget versus actual inventory, recall and warranty processing turnaround times. In the area of learning and growth, VIMS will touch in a more limited way. Its greatest value is not easily measured, but in the proprietary organizational knowledge gained. But what is measurable is profit resulting from VIMS, resulting from our gained knowledge. And finally, we see in the customer area that we can measure year-over-year warranty and recall claims along with customer satisfaction.
Volkswagen demonstrates a strong commitment to information technology, including cloud computing services and continuous enhancements in its data centers. Because of this and the desire to keep proprietary data in-house, we recommend a make approach to data storage and processing. By leveraging VW's cloud architecture, VW can make VIMS data accessible to engineers and analysts around the world, ensuring that the data can be put to the greatest use and provide the greatest benefit. The amount of data to be collected by VIMS depends on the type and number of sensors, how frequently they're sampled, and the type of data that's collected. Testing during the project pilot stage should be used to find a balance between obtaining meaningful data and storage requirements, as well as to drive capacity planning. VIMS data analysis will require specialized skills, and we recommend that it be kept in-house. VW should leverage its existing expertise and partner with vendors such as IBM to develop a customized solution. Technologies geared towards big data, such as Hadoop, should also be considered. VIM's data analysis can be analyzed at two levels, individual and aggregate. Individual analysis can be used to monitor car performance and identify any symptoms of vehicle problems. Aggregate analysis can be used to determine trends and patterns in component behavior across a population. VIMs uses sensors that are built into the warrantied parts of each automobile. These different sensors are networked together and would link to a central module that would be used for storing and transmitting the data. VIMs records data while the vehicle's electrical power is on, not just when the engine is running. Uploads of VIMs data can occur at engine startup to avoid draining the battery, as well as regular intervals while the engine is running. For customer communications, customers could receive emailed alerts if VIMs detects a problem, as well as regular status reports. Dealerships selected by the customer could also receive VIMs alerts so they can validate they have the necessary parts on hand and schedule service with the customer. Communication and service preferences could be managed through the VW Owner's Portal. To maintain data security, VIMs data could be encrypted both during transmission and on the VIMs central module itself. Physical security for the VIMs system is provided by the vehicle's own security systems. To protect customer privacy, VIMs should incorporate foundational principles of privacy by design recommended by Dr. Ann Kavukian, including proactive and preventative measures, privacy by design, and embedded privacy. VIMs should not include GPS, owner, or driver information. Instead of the vehicle's VIN number, a separate, unique identifier could be used for VIMs data. Customer information would be on a limited, need-to-know basis within VW. There are several aspects of human capital that should be considered in order to successfully implement VIMs and keep it running over the long term. The first thing that we need to consider is the additional human resources that will be required. For instance, some of the people required to implement the project will need to devote 100% of their attention to the project at hand and will therefore be unavailable for their regular duties. The second thing to consider is the skill level of employees. The higher the level of skill of employees, the fewer number of employees needed to a certain extent. We plan to utilize the highly skilled employees of Volkswagen where we have subject matter experts and hire additional employees as necessary. The third thing to consider is the organizational structure of Volkswagen. In any project involving transformations of business processes, the organization should consider where the employees are at in the organization so that they have both the authority and the resources necessary to move forward with the project plan. The fourth thing to consider are short-term project members who will be dedicated to the project full-time and plucked from existing human capital. Such temporary roles will include the project champion, the project manager, and the project management team. The fifth thing to consider with regards to human capital is the long-term business continuity through training and retaining the additional employees from the project. Such long-term full-time employees that will be involved with the project would be team leads for various technical areas, mechanical engineers, system administrators, data analysts, big data engineers, customer care representatives, salespeople, IT support, and other stakeholders within the organization. The VIMS project implementation and continuation human capital budget calls for 20 temporary to permanent staff members with a cost of $1.5 million per year over the 3-year implementation period. Continuing years thereafter will require 16 permanent full-time staff members with an approximate cost of $1.6 million per year, which includes a benefit multiplier of 1.67. The project is expected to have a start date of July 1st, 2013 and last for approximately 3 years, ending on August 3rd, 2016. The project will have 5 phases: project initiation, project planning, project execution, project monitor and control, and finally project completion. The majority of the time, the project will be consumed by 3 major tasks: pilot evaluation and adjustment, and rollout. The rollout is planned to coincide with Volkswagen's model year rollout for year 2016. Let's take a look at the VIMS implementation budget. VIMS implementation will have a total budget of $13.65 million over its 3-year implementation cycle. Each year thereafter can expect to incur $2.27 million in continuity costs. Over the 3-year implementation cycle, costs will be incurred to varying degrees as befits need. The software purchase occurs the 2nd year, with annual licensing thereafter. Server and infrastructure purchase costs are all incurred the 1st year, with maintenance estimated at 10% in each subsequent year. Human resources and manufacturing process redesign costs are spread out evenly over the 3 years. The cost-benefit analysis of VIMS implementation shows that it will cost approximately $13.6 million over its 3-year implementation plan into the VW Passat market. Conversely, the estimated benefits of conservative goals to reduce warranty expenses by 10%, or $21.2 million, and to increase sales of VIMS-enabled warranties by 25%, or $119,000, show improvements to the bottom line of $14.4 million. This brings us to our total return amount of $750,000 in the 3 years post-implementation. This equates to a return of investment of 5.52%. We can expect this to increase in future years as further savings are realized through engineering improvements, reduced cycle time of parts and inventory, increased sales of VIMS-enabled extended or enhanced warranties, and other as-yet unexplored possibilities. Volkswagen should utilize both short-term and long-term metrics to measure success of VIMS both during and after implementation. Short-term implementation metrics will utilize evaluative project management cost-benefit tools and techniques. For the VIMS implementation, the most important metric will be around costs, schedule, and quality, with an important focus on communication. Cost and schedule metrics include, but are not limited to, cost performance index, estimate of completion, budget and actual cost variance, and schedule performance index. Measuring quality will be important to VIMS, both in the quality of data that it receives and the quality of the process change that the data will drive through the use of tools such as run charts, control charts, histograms, and Pareto charts. Finally, communication and change management are crucial to the success of the project. Although their progress isn't always quantifiable, the communication guidelines created and followed in the project plan form the foundation for efficiency in managing change to keep the project running optimally. Long-term metrics will occur throughout the project and continue thereafter. Once vehicles roll out and sell with VIMS installed, Volkswagen will be able to use designed scorecards and attendant business performance metrics to measure success, including before and after comparative performance reports regarding manufacturing quality, inventory and supply management, financial warranty sales, and marketing utilization of VIMS data. General, long-term evaluative metrics of the efficacy of VIMS will be performed by the financial departments of Volkswagen, as it is this department's duty to manage financial evaluation and documentation in the ongoing day-to-day operations. These can include financial reports, such as return on investment evaluations on a quarterly or annual basis. This can also track to ensure that the initial 3-year performance targets are being met and can be measured by the investment of implementation and maintenance costs versus the return of fewer warranty claims, reduced manufacturer process cycle times, increased sales of warranties, and increased sales of products due to more precise targeted marketing abilities. Automotive manufacturing is a highly competitive, multi-billion-dollar industry in which Volkswagen has set a goal of becoming the most successful and fascinating automaker in the world by the year 2018. VIMS offers a path to that goal through harnessing the power of big data to provide sustained competitive advantage through knowledge, improvement of VW's product and process design, a long-term benefit of big data on broadening marketing efforts, and to positively impact the bottom line with an ROI of 5.52%. In closing, we urge you to support the implementation of VIMS, a powerful, innovative technology transformation for the unquestionable short and long-term benefits for Volkswagen. Thank you for your time and attention.